if you want to understand what nuclear physics is. I am going to discuss the most important and essential concepts in nuclear physics, so stick with us. Before we start, please subscribe my YouTube channel for more informative videos and press the bell icon. Nuclear physics is the branch of physics that studies atomic nuclei and their constituents and interactions. Examples of nuclear interactions or nuclear reactions include radioactive decay, nuclear fusion and fission. Atoms are made up of positively charged nucleus, surrounded by negatively charged electrons. The nuclei of the atom is made up of neutrons and protons, which is called nucleons. Because protons have positive charge and like charges will repel each other. Forces of repulsion can be calculated by Coulomb's law equation. The force is inversely proportional to the distance between them, r. In nuclei, the protons are close to each other. The electrostatic force between protons are enormous, then what keeps them together against tremendous repulsion, that is strong force, which is called nuclear force, which is 100 times stronger than electrostatic forces, which is known for fundamental forces in universe, the strong force. This force operates at very small distance. It only operates within and between protons and neutrons. The application of nuclear physics lies largely in the field of power generation using nuclear energy. The process of splitting the nucleus to generate energy is known as nuclear fission, and the process of fusing two neutrons to generate energy is known as nuclear fusion. Radius of nucleus. R represents the radius of nucleus. The nature of nuclear force is given as: nuclear forces are attractive in nature. These forces are independent of charges. The range of nuclear forces is short. As the distance between two nucleons reduces, the nuclear force becomes weak between them. The nuclear force is dependent on the spin. Difference between nuclear physics and atomic physics. The main difference between nuclear physics and atomic physics is that nuclear physics deals with the nucleus while atomic physics deals with an entire atom. More specifically, atomic physics deals with the atom as a system consisting of a nucleus and electrons. Nuclear physics deals with the nucleus as a system consisting of nucleons, protons and neutrons. Atomic physics concerns itself with the entire atom and how the electronic configuration of electrons can change. When an atom loses an electron, it becomes positively charged, cations, and when it gains an electron it becomes negatively charged, anions. What is radioactivity? Radioactivity is a nuclear process that occurs due to the decay of the nucleus. Radioactivity is based on the law of conservation of charge. External parameters such as temperature and pressure do not affect the rate of decay. The daughter nuclei will have unique physical and chemical properties, that is different from parent nuclei. The decay rate of any radioactive material is directly proportional to the number of atoms present at that instant. Alpha, beta, and gamma rays are followed during the radioactivity. Applications of nuclear physics. Some important applications of nuclear physics are listed below. Nuclear energy is an essential part of society's energy production. Nuclear energy is produced using a nuclear reactor. Nuclear physics principles have led to great medical diagnostics and therapy methods. One such example is radiation therapy. In radiation therapy, ionizing radiation is used to treat conditions such as thyroid cancer. In archaeology, nuclear solutions are used to identify various stable and radioactive isotopes in archaeological relics. This allows us to uncover the backgrounds of these artifacts. Radioactive elements are used in smoke detectors. Most standard domestic smoke alarms use a radioactive isotope of the element americium to recognize smoke. That's it for today's video. Please like, share and subscribe to my channel.